I find this limit is very interesting. Many points worth discussing, and many points worth sharing here. I believe this is a very good question for those students who are taking the basic calculus course. Now, okay, let's see. This one is going to be infinitive. Therefore, in order to be existing the limit, this inside the limit value has to be 0. Right? This is infinitive. If this is not 0, then the limit does not exist. Okay, so let me first to show that the limit value inside is going to be 0 or not. So let me show this one, okay? That means this limit does this limit goes to be root 15 or not? So we are discussing this limit. 5 1 of x plus 3 1 of x. So let's see what is this limit. If this limit is the root 15, bravo. So the limit could exist. Otherwise, the limit does not exist. I call this one y. And log y is equal to the limit x goes to infinity, x log 2 y plus 3 1 of x. That's quite obvious, right? Now, when x is infinitive, this will be 0. So 5 to 0 is a 1, 3 to 0 is a 1, 2 over 2 is a 1, log 1 is 0. This one's infinity. So therefore the product is kind of an indeterminate form. Now then we have to do something. We put this x below, right? Then this is a natural log 2, 5 1 of x plus 3 1 of x. This one's got to 0. This log 1 is 0, right? Therefore, L'Hopital rules can be applied. Then the limit x goes to infinity. Now this derivative is 1 over negative square. Therefore, flip over becomes negative x squared. Right? Now this derivative is the same derivative as a log 5 1 of x plus 3 over x, right? Because this is constant. The derivative is 0. So this becomes the derivative of this is 3 1 of x, right? That is 1 over this. Multiplied by the derivative of the numerator, which is 5 1 to x times log 5, multiplied by the derivative of 1 of x, which is a negative 1 of x squared, plus, similarly for that one, 3 to the power of 1 of x times log of 3, right? Times negative 1 of x squared. Yeah. Wow. This is, the paper has a hole here. Negative 1 of x squared. Okay. Now, then this is equal to limit x goes to infinity. This one, the other one's common factor. Can be cancel with the other one, right? So this is gone. So it becomes 5 plus 3 to 1 of x and 5 log 5 plus 3 1 of x log 3. Then we take limit. This one is what? This one is 0, therefore it's 1 plus 1 is 2. This one is 1, This is 1. So this is log 5 plus log 3 is equal to 2 log 15, which is equal to log square root 15. Here, log of square root 15 is log y. Therefore, y is equal to root 15, yeah. So we verify that this limit is going to be root 15. Therefore, the inside is 0. The limit could exist because infinity times 0, we can determine whether it's a finite or not. So we can start discussing this limit. Well, we just showed this one is going to be 0. Therefore, this limit could exist. Since this is infinitive, this is 0. I put x to the bottom, right? So we can apply for L'Hopital's rule. Yeah. Now, L'Hopital's rule says the derivative denominator and the derivative of the numerator. Now, to find the derivative of this function, let me develop a formula. Okay. A y of x to the power of x. This is y, right? We want to find the dy dx. That is this. That is the derivative of this one with respect to x. I want to develop a formula first. Now, we take log both sides, right? This is x times log f of x. Then we take both side derivative, right? This one is equal to y derivative over y is equal to log f of x plus x times this derivative. This is plus multiply this derivative, right? So y derivative, which is dy dx, is equal to multiply y over there, right? Y is this function, f of x to the power of x, that is y, multiply this log f of x plus x over f of x times f derivative of x. That is the formula. Okay, another formula for this derivative with respect to x is this. This function, take a derivative with respect to x, is this. Okay, so we need it because we are looking for this derivative. This is what I said at the beginning. See, this question requires many things, which is rather interesting and very basic. Okay, let me do step by step. This derivative is negative 1 over x squared. Then I'll flip over, become this, right? Now, this is the derivative of that. This derivative says, this derivative says f of x dx, that is this, f of x dx. Multiply by log f of x, log, this is f of x, right? Plus x over f of x. This is f of x. Times f derivative, that is this derivative with respect to x, that is this. We did it just in the beginning. Okay, that is the derivative of this one with respect to x. Then I simplify. This 2 cancel out. This one common factor take out, cancel with x, and the positive becomes negative. X put in below. It becomes this. Okay. Okay, this is the reason I pre-written the things, and it makes it better and easier to follow and avoid the mistake. Now, this limit, as we did in the beginning, that's root 15. So I take root 15 out. This is the root 15. Okay. This one, now, okay, I should have written in the front, but sorry, I have written in the back. This one is out root 15. This one is this. This one is this. That one is this. Okay, this one is this. Okay, everything is all right until it reaches this step. Now, from here, I want to simplify the calculation because the calculation is still quite complicated. So let me make a simplification, make it a simplifier. I let t be 1 of x. Then x approach to infinity becomes t approach to 0 from positive side, right? Okay, this negative x squared becomes negative 1 of x t squared. So this is this, huh? I should have written in the beginning. Now, this one is this. This becomes this. X becomes the t on top. This one is this. This one is this. The rest is okay. Now, so everything is convert into t now. It may be better to calculate. Okay. I put this one in denominator. This is t squared. And these two become numerator, right? Negative goes in. There's a negative and a positive. Okay. This one is this. This one is that. Because when you take t equal to 0, this is a 1. This is a 1. So it becomes log 15. This is t squared in the bottom, right? Now let's check again. This one goes to 0. This one is going to be 0 because log 2 over 2 is 0. This one was to 0, therefore 0. So the numerator is 0. The denominator is also go to 0. So we can use L'Hopital's rule. L'Hopital's rule says this derivative is 2t. This derivative is this. This derivative is this. As we did before, right? Yeah. And this derivative is this, because t isn't okay. Now let's check it again. This one, if take t is 0, this is 1, this is 1, is a root 15 on top. This is 1, this is 1, root 15 over 2, negative. This is a root 15 over 2, positive. Therefore, this is 0. This is also equal to 0, right? T goes to 0. So L'Hopital rules apply again. L'Hopital rules apply again. Okay. Well, it's quite. L'Hopital rule, okay. L'Hopital rule says this derivative is 2, right? This derivative is 2. And this derivative 0 is gone. This derivative you have to use the quotient rule. Quotient rule says this is square. This is square, right? This is square. And the numerator derivative Now, here I took negative outside, sorry, because to make it simplify, this negative is going out, so this is negative, this is positive. So this derivative is quotient rule. The denominator is this is square. Numerator derivative, this derivative, which is this, multiplied by the denominator minus numerator, which is this one, times the derivative of the denominator. The denominator derivative is this. Okay. I hope not mislead. Okay, I try again. Here, I take negative out. Negative out. I take negative out. So this is negative. This is positive. This is negative. Now, I take a derivative with this one with respect to t. That will use the quotient rule. So this square, the numerator is this derivative, which is this, times the denominator, which is this, minus the numerator, which is this, times the derivative of the denominator, which is this. Okay. I hope things are right. Then we take limit. This is 1 plus 1, 2 square times 2 is 8. Then this is 0, right? Is a 1. This is log 5 square plus log 3 square times 2. This is 2. And this is log 5 plus log 3. Log 5 plus log 3 becomes log 5 plus log 3 square. Now from here, just simple calculations. Negative root 15, that is this one. This is 8. Now this one times this one is this. This time this one is this. This square is this square minus 2 this because negative here, right? Then this one and that one become this. This one become this. So these three become this. And this is log 5 over 3 square down there. So this is our limit value for our target limit. Okay, now finally we have a question. Why this value is negative? Why is it negative? Okay, let me go from the very beginning. Okay, this is the limit, very limit we are talking about in the beginning, right? Why this limit value is negative? Because look, x is approaching to infinity. So this is a positive. So this is the exponential function. As the exponent is positive, the base is positive. Therefore, this function is an increasing function. We know that this limit is root 15. Therefore, this limit must approach to root 15 from below. Therefore, this limit is always less than root 15. It's approaching to root 15, but from below. Therefore, the difference The difference is almost zero, but negative. This is a very small negative number. This is positive. Therefore, this product is negative. This is the reason why, our final value is this, negative. Well, I hope this that explains. Okay, thank you very much.